Here we're going to look at topic 9, example 3, sketch the graph of a linear equation in point-slope form. The question is, what is the graph of y minus 3 equals negative 2/3 x plus 1? So let's take this equation and rewrite it. And remember that this is in point-slope form. So this is in the form y minus y1 equals m times x minus x1. What we need to be careful of, if we're trying to kind of pull the point from the equation, you want to watch out for your signs. So notice that we have this y minus y1. So if it's y minus 3, this value here is really just a 3, right? That y1 is 3. But we need to be careful of this sign here. This plus 1 doesn't match up with that minus x1. So what we really have is we have y, sorry, wrong marker. We have y minus 3 is equal to negative 2/3 times x minus negative 1, right? Because this minus negative 1 is what turned into that plus 1. Okay, so I want to be careful with that. The signs are always kind of going to be opposite, and you'll see what happens. But in point slope form, our point, right, is our x1, y1, and our x1 is right here, which is negative 1. Our y1 is the point that was here, which is our value of 3. Okay, so you want to be very careful. The more you do these, the quicker you'll be able to go through that process. You won't need to write all the steps. You'll just realize that what you originally have, in this case this minus 3, becomes a positive 3. This positive 1 becomes a minus 1, okay, or a negative 1. Okay. But as you get better at that, you'll see that. So we can plot that point. That negative 1, 3 would go right here. And now we also know our slope, because right, we're dealing with point slope. We know our slope is negative 2 over 3. Remember, that's equal to our rise over run. So we want to rise negative 2. So we're going to go down 2 places and then run 3. So 1, 2, 3. And then put a second point there. It's quite similar to what we did in the previous section with slope-intercept, where we plotted the y-intercept and then counted the rise and the run from there. This time we're not counting from the y-intercept, we're counting from the point that we pulled from our point-slope form. So I would then connect the dots. So my graph would look something like this. Make sure that line's straight. Draw arrows because this line continues forever in both directions. And that's the graph of my equation. All right, really, just please be careful finding the points, the actual xy coordinate points, pulling them out of the equation. They're going to wind up being the opposite. So just be careful of that. That's really the only issue you can run into with these. Once you have that first initial point, then counting from the slope, the rise, and the run is pretty easy. You shouldn't have too much trouble with that.